You've seen the videos, right? It's night over Tel Aviv. The sirens are wailing, and suddenly these glowing streaks shoot up into the darkness. They curve, they adjust, and then, boom! A flash of light and the threat is gone. It honestly looks like science fiction.
It looks like Star Wars. It's visceral.
Exactly. But here's the thing that keeps me up at night. When we look at that, are we looking at a miracle of modern engineering? Or are we looking at a very expensive, very temporary band aid? Because the math of shooting a bullet with another bullet, it feels impossible.
It feels impossible because for a long time it was, but to answer your question, is it excellence or just a shotgun approach? It is absolute engineering excellence, but not for the reason most people think.
How so? Because from the outside, it looks like the interceptor missile is the star of the show.
That's the visible part, sure. That's the Tamir interceptor. But the real genius, the brain that makes the Iron Dome what it is the Battle Management and Control System, the BMC. See, most traditional defense systems are paranoid. They try to hit everything that moves.
Which sounds safer, doesn't it? Better safe than sorry.
In theory, yes. In practice, it's bankruptcy. If you shoot at everything, you run out of ammo in minutes. The Iron Dome is different. It's selective. It's practically an accountant. Within seconds of a rocket launch, the radar tracks the trajectory and the BMC runs a projection. It asks, where does this land?
And if the answer is an empty field,
It does nothing. It lets it fall. It ignores it.
that takes a terrifying amount of trust in the algorithm. You're standing there watching a rocket arc toward you, and the system just decides, nah, you're fine.
It's cold, hard calculus. But that decision saves the system. It saves the world of the bullets for the threats that are actually heading toward a populated area or a critical asset. And that brings us to the economics of this, which is just as important as the physics.
Right? Because these interceptors aren't cheap.
They aren't free, no. A Tamir interceptor costs somewhere between $40,000 and $50,000 per shot.
Which sounds like a lot for a single-use item.
It sounds like a lot until you compare it to a Patriot missile, which can run you $3 or $4 million a pop. The Tamir is a bargain, and the engineering feat that allows that price point is the miniaturization. They managed to cram active radar seekers, the eyes of the missile, right into the nose of a relatively small, agile rocket. It's not just blindly following a path, it's hunting.
So we have a smart, relatively cheap shield that only blocks the punches that matter. It sounds perfect.
It sounds perfect, but in engineering, the perfect is just a word for we haven't found the breaking point yet.
And I assume there is a breaking point?
Oh, absolutely, and it's not about technology, it's about simple, brutal arithmetic. It's a concept called saturation.
I can guess where this is going. If I throw one rock at you, you can catch it. If I throw 100,
Exactly. It's a classic queuing theory problem. Imagine a supermarket with 10 checkout lanes. If 10 people show up, everyone gets served immediately. If 100 people show up at the exact same second, you have a bottleneck. An Iron Dome battery has a finite number of interceptors it can fire, and more importantly, a finite number of targets its radar can track simultaneously.
so if an adversary knows the math,
They just do the math in reverse. If they know a battery can track 40 targets, they fire 100 rockets. 40 get engaged, maybe a few miss, but 60 are getting through. The system isn't broken, it's just overwhelmed.
that's terrifying. It turns defense into a numbers game.
Warfare has always been a numbers game, but the Iron Dome was designed primarily for short-range ballistic threats. We call them dumb rockets.
Dumb because they don't have guidance?
Dumb because they follow gravity. They fly in a parabola, an arc. Once the rocket engine cuts off, physics dictates exactly where it will go. It's predictable. The computer looks at the arc, calculates the future, and meets it there.
Okay, so what happens when the threat gets smart? I'm hearing a lot lately about hypersonic missiles.
That is where the Iron Dome, and frankly, most current air defense, hits a brick wall.
Because of the speed?
Speed is part of it. We're talking above Mach 5. But speed alone isn't the issue. We can track fast things. The problem is maneuverability.
They don't fly in an arc?
No. A hypersonic glide vehicle stays low within the atmosphere and it can change direction. It zigs and zags at 4,000 miles per hour,
So the Iron Dome's computer is trying to predict a parabola.
and the target takes a sharp left turn, The algorithm effectively tries to divide by zero. It can't calculate an intercept point because the target is actively changing its future. You can't shoot where the target will be if the target hasn't decided where it's going yet.
That sounds like checkmate. If you can't predict it, you can't hit it.
Not with a bullet, no. Trying to hit a maneuvering hypersonic missile with another missile is like trying to shoot a fly out of the air with a handgun while the fly is on caffeine. The physics just don't favor the defender.
So, if the steel umbrella is leaking and these hypersonic lightning bolts are coming, what's the next move? Do we just build faster missiles?
You can try, but you hit the limits of propulsion. The next frontier isn't about better matter, it's about energy, directed energy.
Lasers.
Lasers. Israel is already testing the Iron Beam. This flips the script entirely. Remember we talked about the cost? $50,000 for a Tamir interceptor?
Right.
The cost per shot for the Iron Beam is estimated at about $2.
$2? That's basically the cost of the electricity?
Exactly. You have an infinite magazine as long as you have a generator, but the real advantage isn't the cost. It's the physics. A laser travels at the speed of light.
So there's no travel time.
Zero. Well, negligible. With a missile, you have to lead the target. Aim where it's going to be in 5 seconds. With a laser, you aim where it is right now. If you can see it, you can hit it.
That solves the maneuverability problem then. It doesn't matter if the hypersonic missile zigs, the laser gets there instantly.
In theory, yes. It cooks the electronics or heats the warhead until it detonates, but lasers are finicky.
There's always a but.
Physics again. Lasers are light. What happens to light when it hits fog, or smoke, or a sandstorm?
It scatters, it loses focus.
Precisely. The Iron Beam is incredible on a clear day. In a heavy storm, or if the enemy uses smoke screens, it becomes a very expensive flashlight. It can't replace the Iron Dome, it complements it. But to truly stop the hypersonic threat, the ones that stay low and fast, we need to fix the eyes of the system.
The radar.
Bigger than radar, we need to go up. We are moving the entire sensory apparatus into space, low Earth orbit.
Satellites?
A constellation of them. It's called HBTSS, Hypersonic and Ballistic Tracking Space Sensor. See, ground radar is limited by the curvature of the Earth. A hypersonic missile stays low, under the radar, literally, until it's too late.
So you put the eyes in the sky looking down.
Right. You need to see the launch the second the heat signature flares up, and you need to track it through the entire glide phase. But here's the engineering nightmare. It's not just one satellite. It's hundreds, all talking to each other, passing the track from one to the next as the missile screams across the globe.
It sounds like a data problem as much as a defense problem.
It is entirely a data problem. The challenge isn't the explosion anymore, it's latency. Can satellite A tell satellite B where the target is, and can satellite B tell the interceptor on the ground where to shoot, all in the span of a few seconds? If your data lags by half a second, you miss by miles.
So the future of defense isn't a thicker shield, it's a faster brain.
That's the only way to survive. We are moving from a war of ballistics to a war of processing speed.
It really changes how you look at the sky. We started this talking about the Iron Dome as this ultimate shield, proving we could hit a bullet with a bullet.
And we did prove that. It's a marvel. But warfare evolves. The next generation has to prove we can hit a ghost, something that moves unpredictably, with a beam of light, guided by a computer floating in space.
It feels like we're approaching a point where the human reaction time is completely irrelevant. The systems are fighting each other, and we're just living under the result.
We crossed that line a long time ago. We're just now realizing how fast the game is actually being played.
A sobering thought to end on. We'll be watching the skies and the data very closely. Thanks for breaking down the math behind the miracle.
Anytime.
And for our listeners, if you want to know more about exactly how a fiber laser cuts through steel in milliseconds, let us know. We might just do a deep dive on the Iron Beam next time. Stay safe out there.